Welcome to The Explainer. Today, we are going to pull back the curtain on this hidden mathematical blueprint that economists use to try and model your decisions. Yeah, every single one of them.
So let's just start with a question for you. Are your choices perfectly logical? I mean, really think about it for a second. That coffee you grabbed this morning, the career path you're on right now, does every single one of those decisions follow some kind of perfectly consistent internal rulebook?
Yeah, probably not, right? Most of us would say, no way. But here's the thing. For a long, long time, economics has been obsessed with exactly that idea, building this formal mathematical foundation, a blueprint, to try and understand and even predict the choices we make.
And this blueprint, it's built on something called an axiomatic approach. Okay, that sounds fancy, but all it really means is starting with a few super fundamental, almost self-evident rules, they call them axioms, to define what it even means to be rational in the first place.
All right, so let's dive into the original blueprint, the one that really started this whole thing, what we call classical rationality.
And the logic here is actually pretty elegant. It all starts with these simple rules of consistency. Like, if you prefer apples over bananas and bananas over cherries, then you have to prefer apples over cherries. Make sense, right? And from simple rules like that, you can actually build out a whole map of a person's preferences. And the big conclusion from all this? A rational person will always, and I mean always, choose the option that puts them right at the top of their own preference map.
So here's the key takeaway. In this perfect classical model, every decision is basically just an equation. Uncertainty? That's just probability. Your personal preferences? We can measure that as something called utility. And the one and only goal is to get as much of that utility as you can. It's simple, it's clean, and it's supposed to be super predictive. But is it really?
Because what happens when the world isn't so neat and tidy? What happens when we have to make decisions without actually knowing all the odds?
Okay, and this is where we have to make a really important distinction. See, the classical model is fantastic at handling what we call risk. Think about a coin flip, right? The odds, 50-50. But it really starts to fall apart when it comes to ambiguity. And that's when the probabilities themselves are a total mystery. And that brings us to this brilliant little thought experiment that really showed a major crack in this whole blueprint. It's called the Ellsberg paradox. And the setup is super simple. Imagine you've got two urns in front of you, each with 100 balls inside. You win $100 if you draw a red ball. Easy enough.
So here's the choice you have to make. Urn 1 is our risky urn. You know exactly what you're getting into. 50 red, 50 black. A straight 50-50 shot. Then you have urn 2, the ambiguous one. It has 100 red and black balls, but you have no idea what the mix is. It could be 99 red balls, or it could be 0. You just don't know. So which one do you pick? Well, what happens is, overwhelmingly, people go for urn 1. We prefer the known odds. And there's a name for this. It's called ambiguity aversion.
And right there, that's the bombshell. Because according to the pure, cold logic of that economic blueprint, there is absolutely no reason to prefer urn 1. I mean, for all you know, urn 2 has way better odds. A truly rational machine shouldn't care about the unknown. But we do, don't we? That very human, gut-level feeling of preferring certainty, well, it's completely invisible to the classical model. It's a huge crack in the foundation, and it shows that this blueprint isn't a perfect map of how we actually think.
So this really brings us to the central conflict here, doesn't it? It's the perfect logical model on one side and real, messy human behavior on the other. And this contrast lays out two fundamentally different ways of looking at the world. The axiomatic models from economics, they're what we call normative. They're all about how a perfectly logical person should behave. But then you have behavioral science, and that's descriptive. It's about observing how we actually do behave, with all our predictable quirks and biases.
And this is so important. The point isn't that people are just irrational. No, instead, behavioral scientists came up with this idea called bounded rationality. And what it suggests is that, look, maybe we aren't the perfect little calculators that the classical model imagines us to be. But our behavior isn't just random either. It's based on pretty reasonable systematic principles. They're just bounded or limited by the messiness and uncertainty of the real world.
Okay, so this all begs a pretty big question, right? If this blueprint is so flawed, if it doesn't really match reality, then why on earth do economists still rely on it so much?
Well, the answer is that its purpose was never really to be a perfect photograph of reality. What it does give us is a really solid logical framework for just thinking about choice.
It acts as a benchmark, a starting point that lets us measure and understand our own so-called irrational behavior. And maybe most importantly, it's the foundation for all the newer, more complex models that are trying to account for things like our dislike of ambiguity.
At the end of the day, it's really about defining the ideal rules of the game. Think of it as the mathematical blueprint that precisely lays out all the conditions you'd need for perfectly logical, consistent behavior. Even if we, as the players in that game, don't always follow those rules to the letter.
And all this leaves us with a final and pretty provocative thought. If we know that the blueprint is just a guide, that it's an idealized map, but it's not the actual territory, then what's the next step? How do we go about designing better economic systems, better policies, for the imperfect, but still pretty reasonable real-world human beings that we all are?